looking over this in a little more detail, I noticed something. So here, when we're using variables, our numbers don't have to have the same name. So why should we assume that the names of the numbers have to be the same here? Right? So in this system here, if I take 2 and our definition of 1 is our current location, right, then we're going to dynamically, we're like at 2, when we add 1 to it, we're going to dynamically recalibrate our unit to our current location, and that's going to bring us here. And that's actually totally fine, because now what happens is you get here, you get a 2 equals 1 right here. And what ends up happening is the successor to 2 is 3, and that is exactly the same as the successor to that 1, which would be 2. So this actually remains consistent with these axioms. This sort of numbering line, this sort of number line, this sort of number system, is absolutely not the natural numbers. And the way that you would normally think that addition and multiplication, probably, I haven't looked at it, should operate, won't work quite. But it is consistent with these rules. Because of the things that haven't been defined. The things that haven't been defined leave openings that make this totally fine. That's amazing. I also find it interesting. One of the things I noticed early on, actually, I just didn't mention it. Mathematicians, the mathematicians that I've known, are in terms of like programming and whatever, they're really big fans of functional programming languages because they don't like state. Right? They want to avoid state as much as possible because, for whatever reason in their mind, the way that their minds operate, state is kind of their weak spot, right? But it's interesting to me that the only way that you could get this to produce natural numbers, the actual natural numbers, is in if we force the initial 1 to be our unit forever. If that 1 is stateful. If we leave it to be dynamically defined, like you would in a functional programming language, or other situations that mathematicians tend to favor, something like this, as the numbering system resultant from these axioms, should arise. So I find that interesting. I find it interesting that, on one hand, mathematicians strongly disfavor state, but on the other hand, they accept this because they're assuming state. Yeah, some interesting things going on here. So yeah, I'm gonna have to say that I disagree with the conventional modern foundations of mathematics, I don't think that it's been done correctly, personally.